All right, welcome, ladies and gentlemen, to the beginning of our chapter 2. We're going to be looking at modeling with linear and quadratic equations. We're actually going to be looking mostly today at how to use a calculator with scatter plots and two types of regression models. And here we go. We're going to go right into this. You're going to need your textbook because we're going to use the table of values from the textbook. And hopefully you have a calculator handy. If not, when you come in tomorrow, make sure you can do this stuff before you start your assignment. All right, so a couple things you should know by now. Linear functions. We should know a linear function by now, what it looks like, what are the parts of a linear function, all that sort of stuff. That's stuff we learned way back in pre-algebra, good probably 4 years ago. This is a degree 1 polynomial. Basically because it's x to the first power. It's y equals mx plus b. This is actually x to the first power. It's a degree 1 polynomial. You might remember your degrees or your clarification of degrees from Algebra 2. This is your slope equation. Again, something we should know by now. This just says f of x sub 2 minus f of x sub 1. Sorry, that's a typo there. That should say x1 all over x2 minus x1. This is the average rate of change. This is slope. Whatever word you want to work with there, it's the same idea. But that's our more higher math level of looking at what the slope looks like. The slope-intercept form of a line is f of x equals mx plus b, where our m is our slope and our b is our y-intercept. The point-slope formula, or point-slope form of a line, is y equals, or f of x equals m times x minus x1 plus y1. This is a very handy one to know because it's a very handy to know when you get to calculus. So those of you juniors, sophomores that are going to come see me next year for calculus, this is a very handy equation to remember. So this is if you're given a slope is some number and some coordinate like 2, 3, which is your x1, y1. So you can plug in x1, y1. As long as you know a slope and a point, you can plug it in and there's your equation. Done. The last thing here is you need to remember that f of 3 equals 2 means the coordinate 3, 2, because this says that x is 3 and y is 2, or y is 2 when x is 3. All right, and that goes for just more than just linear functions. That goes for any type of functions. F of 3 equals 2 is a coordinate 3, 2. Okay, again, one more thing we should know. Quadratic functions. This is our degree 2 polynomial. This is vertex form. I don't know why I didn't write that in there. This is vertex form. And the vertex is HK. And I didn't write it in here, but standard form is ax squared plus bx plus c is equal to f of x. That's standard form. And vertex form is that a times x minus 8 squared plus k given a vertex of hk. And you should obviously know the quadratic formula by now. So let's move on to stuff we don't know just yet. The first one is the vertical free fall equation. Some of you may have seen this in physics. This is the version that we give you here in trigonometry. S of t is a position function, which means how far things have traveled. And v of t is a velocity equation. So there's different things on here. Depending on the question being asked, Actually, not depending, but in this case, g represents gravity, or the acceleration of gravity. And if you have a problem dealing in feet, you're going to use 32 for g. And if you're dealing in meters, you're going to use g equals 9.8 in either of these equations. V sub 0, or sometimes I call it V sub aught. V sub 0 is the initial velocity, or the starting velocity. S sub 0 is the initial height. So wherever you started from above the ground. Oops. So if I said, write the position function for an initial velocity of 6 meters per second with an initial height of 3 meters. Since the problem is dealing with meters, I'm going to use g as 9.8. And I'm going to say s of t is equal to 1/2 of 9.8 is 4.9. T squared plus 6t plus 3. So my initial height, sorry, that's supposed to be s of 0. Initial height was 3 meters, so 3. My initial velocity was 6. And I could say, oh, for that, the velocity function is going to be negative 9.8 t plus initial velocity, which was 6. And that's pretty simple, straightforward. Gives you enough information in every problem to write some equations depending on the problem itself. Okay, let's move on to stuffs you really don't know yet. And this is going to have to do with scatter plots. Now, everybody seems to think they know scatter plots because back in Algebra 1, we asked you to draw some scatter plots. And we were going to say, oh, does this have a correlation? Well, yeah, it looks like it has a positive correlation. But not all scatter plots have nice linear answers. This is a line of best fit. Line of best fit, or a regression line. Regression. Don't ask me why they call it that, because I don't know. It's just the title that we're giving it. But not all scatter plots look like it could be done with a line. Some of it looks like it could be this, where the scattered dots go in some sort of curve. And what we're going to be dealing with is the calculator itself. So I kind of took a picture here of what the calculator is going to look like, because you know what it should look like. And we're going to turn to page 167, and we're going to look at table 2.2. And on that table, it gives you a list of price per box and boxes sold. And here's what we're going to do. You're going to go into your calculator, and you're going to hit the stat button. This is going to come very handy for us when we are doing these scatter plots. That is the stat button, or statistics. And what you're going to do is you're going to go over and hit edit. Or actually, it's going to be up. It's going to be the first thing that shows up when you hit stat and edit. And under L1, you're going to put in the price per box. And I'm going to do this here now as well, so I have everything in front of me. I'll give you a second. And under L2, you're going to put the number of boxes sold. All right. Once you have that done, always double check. Make sure you didn't make any typos along the way, because you're not going to want to have a typo anywhere along the way. Now, what we're going to do is you're going to go to graph, and we're going to graph that scatter plot. So if you go into your y equals, and you're going to hit plot 1. But we actually need to go into something else before that. Actually, we don't. All we have to do is actually go into your window. And we're going to change our window. This is new for most of you. There's a button right up here at the top that says window. And these values coincide to X min. This is X max. This is Y min and Y max. It's the smallest X value that we want on the screen and the largest X value we want on the screen. And I get that from looking at the table of values. My smallest X value is 2.4. So I'm going to go a little bit less than that. So I'm going to change my window to 2.0. And I'm going to give my biggest, which my biggest is 3.6, so I'm going to go a little bit above that, so I'm going to say 4. The XSCL means scale. And for this one, just leave the X's as 1. But then go down and change your Y minimum to 15,000 and 40,000 for your largest Y value or your Y max. Now, you can change your Y scale if you want to. I usually do. I'm just going to make it worth like 10,000 just for the heck of it. And I'm going to go ahead and graph. Once you have this changed, go ahead and graph, and you should have something on your screen that looks like this. You should probably just have some dashes over here somewhere, dashes down here, whatever. But you should have dots that look a little bit like that. And it does actually look linear. So because it looks linear, I'm going to do what's called a linear regression. So you need to go back into your stat. You need to go over to calc and go down to the one that says lin reg, and then next to it, it's got AX plus B, which is your number 4. If you hit enter, it asks you some things. It asks you for list 1, or sorry, X list and Y list. It should just be basically L1, L2. But go down to store reg. So where it says store regression equation, ... right in there, I want you to put in Y1. So go alpha trace and type in Y1. And then hit enter, and then go down and hit calculate. Once it calculates for you, it's going to calculate, and it's going to say on your screen, if you plugged in everything in correctly, it should say y equals ax plus b, and it gives me a is equal to negative 15358.92857, and b is equal to 73622.5. Now, it used to be where you had to write that stuff down so you can plug it back into your calculator. But because you saved it into Y1, if you go into your Y equals, you should now have that equation. And what you can do is you can go to graph, and now your graph has your scatter plot that looks like this, and your line that goes directly through the middle, and you've now created a regression equation. And then I could ask some questions. Like, how many boxes are you going to sell if you made it worth, I don't know, let's say $3.50 or $3.90? You have a regression equation now, and you can actually go straight into your home screen on your calculator and type in y1 of 3.5 and y1 of 3.9. If you do that, you're going to get out answers. So if you do that, y1 of 3.5 says I'll sell around 19,866 boxes. And if I go to Y1 of 3.9, I get about 13,700 boxes. All right, so that's linear regression. Let's go ahead and do one more here. Let's go to a different table, page 174. We're going to go to table 2.3. So we're going to move forward quite a ways there. And what you're going to do is you're going to do the same thing. Your X is your time. So X, or actually, sorry, your list 1 is time, and your list 2 is height. And what I am going to have us do there is you can do this as you see fit, but if you look to the next page, 175, you'll notice that it gives you a scatter plot that looks like this, essentially. And that looks like it's quadratic. And since it looks quadratic, I'm going to use the quadratic regression. And the process is still the same. You go to your quadratic regression. You can plug in, or make sure you have L1 and L2 in your calculator as written. You use your quadratic regression. You can get an equation. The equation that they give you here is on page 174. And then you can actually use that equation to find the zero of the function, or where it crosses the x-axis. In this particular case, it was where the ball hits the ground, or whatever they're doing here, the rubber air-filled ball, okay, where it would hit the ground. All right, so there's lots of things you can do with scatter plots, and this regression line helps us to predict what would happen in the future if that pattern continued. And the pattern meaning the equation, or the regression line, the scatter plot itself. All right, I'm going to leave you guys with that. Here is your assignment. Have a good evening. I hope you learned something. I'll see you guys tomorrow.